Okay. I cannot find my code where I solved this lab. I don't remember what I've done with it, so I guess I'll have to rewrite it. What I've done is I've brought up some students' code from the past. This is one of the better ones. And the last time I taught this semester, about a year ago, there wasn't a single student that succeeded in getting all of the code working. But all the students learned a tremendous amount about programming the Arduino. The focus of this class is not programming the Arduino, it's mechatronics. We just need a platform to do it on. So that's what the first bit of the course is about, is learning to program Arduino. So I try to give you guys as much as quickly as I can, and the best way I know to have you learn is basically throwing you into the deep end and saying, here, swim, and then helping you. Okay? So like I said, one of the best ways to learn how to program is to see sample code. Now this code's not perfect, but it'll help illustrate some ideas. What I haven't told you about is something called interrupts. Interrupts are very valuable because they allow you to have the microprocessor set aside whatever it's doing and go take care of something else. For example, you could set up some code with a loop that constantly checks a button input, right? It constantly looks for a button input. Well, that's not very efficient. Wouldn't it be nice if the button was pressed, it would interrupt the processor automatically, okay, by the button being pressed, and the processor could go and deal with the fact that the button's been pressed. Maybe set a variable to 1 so that it remembers that that button has been pressed, that input has been triggered, okay? And then once whatever that input's supposed to trigger, like shooting a missile at the alien ship or whatever, okay, in the context of a game, then you clear their memory that the button has been pressed. Okay, now that type of interrupt is an event-based interrupt. Something has happened, basically. There's an input that has triggered an interrupt to the processor. There are also timing-based interrupts, and that's what we're more interested in, I think, for this lab, is a timer-based interrupt. I've got a circuit set up down here, and I'll try to hold it up for the sake of the camera. It's a pretty straightforward circuit. The program that's up here is actually running right now. Let me hold it up. There we go. You can probably see the LEDs flashing a bit on the camera. I can't tell for sure, but the LEDs down here are flashing. The Arduino is running the program. Basically, there's 2 buttons set up, and the speaker is not connected. The reason is because the student did not succeed in getting the sound to work. One of the reasons I'm having you guys work in groups is because no single student succeeded at this, so I had it assigned to each individual student. Thought maybe you guys could succeed and get farther in teams. Even if you don't succeed completely, my goal is for you to learn Arduino coding. All right, so you'll pick up a bunch of stuff, I think, through this challenge. Anyway, let's look through the code that this student used and see if we can understand it. So int rand LED, that's the random LED, he set it to 2 initially. So he's commented his code well, which is something I'm going to look for. That's one of the main things I will look for in giving you credit for this lab. Not so much that your code works, but that you tried to get all of it to work and hopefully gotten most of it to work, and that you commented your code, because commenting your code is what allows you to go back later and understand what you did more quickly, because it's very important. Variable for which LED to light up between 2 and 9. So basically, I'm not sure why he said between 2 and 9, but he had 8 LEDs, which is what the lab requires. Difficulty 200. This is the LED blink speed in milliseconds. You can tell that from the comments. So it's basically how fast the LEDs, how fast the game's going to go, is what that is. These are all just pin numbers, so LED 0, 1, all the way through 7. He's assigning to particular pin numbers on the Arduino. Okay. Int coin in2 button 3. These are where inputs will come in, so these are just the pin numbers that are going to be used for input. So these are the output pin numbers. These are the input pin numbers. Boolean. Well, what's a Boolean type? Well, it's a 0 or 1. It's a bit. It's either true or false. Okay. Coin inserted, he initially sets it to false. So this is a variable. Why use a coin inserted Boolean rather than just an integer here? Anybody know?
Take up less space.
It takes up less space, exactly. So it takes up less space in memory. And we're still not out. You see where I uploaded it. It's only, what, 16%? And then 12%. This is hardly using anything in the Arduino, but it's good practice, especially, it's also good practice to do this from a user readability standpoint, because you know that this is a variable that's either true or false. It's not something that can take on any number. If it was an int, you would know it could take on any number, right? And maybe 0 means false and 1 means true. this programmer wouldn't be using the entire range of the variable, and so it's clearer to the reader what this is supposed to do. Okay, here's something that's commented out. I don't know what he was trying to do there. It's not operated in the program. Int special LED equals 125. Create a variable for the winning LED. I don't know why I set it to 125. I think this is going to be an LED number, basically, one of these pins. But anyway, volatile int win pick equals 0. Well, now we're getting into the interrupt side of things. See, here's the thing. When you have your main code running and something happens where an interrupt is called, well, it could be that your main code is looking at a variable and checking every now and then to see if it's changed. Okay, not all the time, but maybe it's just controlling the program flow based on whether that variable is true or false. Well, if an interrupt can also have access to that same variable and change it, then basically the compiler can become confused, is the way I'll describe it. And so it's important, any variable that you're going to reference inside of a interrupt service routine, an interrupt function, something that's called when an event is triggered, and other sections of code needs to be defined as volatile. Does that make sense? So what does volatile mean? Don't worry about it right now. Just anytime you make a variable that's going to be referenced in the interrupt service routine and a main routine, make it a volatile and it'll save you problems later on. Okay? So these variables are all variables that are going to be used in the context of some type of interrupt, probably. Now, it won't hurt you to set these volatiles, so you can just do that immediately if you want. He defined a string. I don't remember what that was for. He doesn't have a comment for it, so we don't know. Let's scroll down in the code. We've got a few more variables here that he's defined as ints. Void setup. He had this commented out. I have uncommented it because one way to troubleshoot your code is to actually bring up a serial monitor and print out information to the serial screen. So all this does is it sets up the Arduino so the Arduino will be able to print out to this window. And actually you can send information from this window to the Arduino, but I'm not doing that right now. All I wanted to do is use this as a troubleshooting method. Okay? So it's set up to 9600 baud. That's the communication rate. You'll notice that the serial port is set up to, or the serial monitor is set up to receive at 9600 baud, receive and send actually. You can change that rate, but the higher the rate, the more time the serial port takes. Well, the more time it takes from the processor, although the communication can be quicker. Anyway, so pin mode, here's where we're just setting the pin mode of all the output LEDs and the inputs for the buttons. So that's pretty straightforward, and I think you guys understand that now. Attach interrupt. Here's something new. Now, I'm going to say this because the Anderson site is using Arduino Megas instead of Arduino Unos. It's what they happen to have on hand. The way the interrupts work are a little bit different between the various flavors of Arduino. Okay, so attach interrupt. This is a command that basically tells the Arduino, hey, there's a input pin you need to monitor. And when that input pin changes by some predefined way, you need to call a subroutine. So digital pin to interrupt references the particular pin that's supposed to cause. See, this student is using event-based interrupts, not timer-based interrupts. Okay, so when a button's pressed, when the coin in button pressed, then this command means that the Arduino will be monitoring that pin and will automatically call the function play whenever the input is falling. Does that make sense? See, the input is, it depends on how you have it set up. If you got it set up so that the switch, when it's open, is pulled down to ground with a pull-down resistor, then when you close the switch connects that pin to positive so that the pin goes high. That's the way most people will do it. Okay, so most of the time that input pin, because the button's not pressed, will be down at 0. But whenever the button's pressed, the connection will be made to positive 5 volts, and that input will go high, right? It will remain high as long as the button's pressed. When the button is pressed and the input changes from low to high, that's called a rising edge. Okay, and you can use rising as a keyword. So this event is triggered not just on whether the button is high or low, but on the fact that the button was rising, that it was changing state, you see? Now, in this case, he chose falling. What do you think that means? That's when the button's released, right? So the input goes from high to low. That's what triggers the interrupt. So the keywords you can use here are low, high, falling, and rising. Those are the 4 things you can use. Now you can just put coin in here. It's not recommended. I don't remember why. We just use digital pin to interrupt like this and put the coin or the input number inside of this function. So you can look this up on Arduino's website if you want to. I'll take you there. Let's see. I was looking up some of the other things that they have now. In fact, I think I can just go back. Yeah, attach interrupt. Okay. The Uno, the Nano, the Mini, other 328 base. 328 is the processor. It's a microcontroller. It's an Atmel 328 based microcontroller. For the ones we're using, the Uno, only pin 2 and 3 can be used to trigger interrupts. So now do you see why this student hooked up the buttons to pins 2 and 3? So that those buttons could trigger interrupt functions. Okay. On the Mega, which Anderson has, pin 2, 3, 18, 19, 20, and 21 can be used. Now we don't have pins 18 through 21 as inputs on our little Arduinos. Okay. So it just varies a little bit. But anyway, there's a lot of good information here, but I want to bring your attention to this first of all, that this is the syntax that's recommended for attaching an interrupt to an input pin. Okay? So the interrupt service routine, the function that's going to be called when that pin is changed to whatever the mode we recommend, or we decide whether that mode is low, rising, falling, or change. I was wrong. High. Let's see. It's a couple of boards that allow high also, but I guess our Uno does not allow high. But change, rising, falling, and low. I forgot about change. Are the modes that are allowed on our Uno, and would be on the Mega as well, because this is not talking about the Mega down here. This will work, but is not recommended. It causes trouble, and I can't remember how and why. And this will work, but only on these models, and it's not recommended anyway. So this will be the syntax we'll always use as the supplement. Okay. So the number of the interrupt, the pin number, and the interrupt service routine. Okay, so that's an example, but I don't want to go through that one. I want to go back to the code that we had. Now, the interrupts that are being used in this student's code and that I just showed you on Arduino's website are event-based interrupts, and those are frequently the most valuable, but in our case, I think a timer interrupt would be better. Now, I looked again earlier today on Arduino's website, and they don't have a real good write-up about how to use a timer-based interrupt. So I'm going to post a link that I found, and I'm not trying to teach you guys all the details right now. We'll probably work on this a little bit more next class, because we're running out of time today. But I found a really nice instructable, of all things, that's really well written about how to use timer-based interrupts. So I'm going to put this into the course website as a link, but I'll go through it. I don't expect you guys to go through this in a lot of detail. I'll go through it with you. And I have to wrap my head around this too. I've not used a timer interrupt like this before, but it sounds really good. I've used a timer interrupt, but not this way. The way I did it was, I don't know if you guys know what Adafruit is. It's kind of like SparkFun. It's an electronic supply place, and they have a lot of good Arduino-based stuff. But there's an art. They also have a lot of learning information as well. And the way they did it, let's see, part 2. I think that's okay. Yeah. This will seem a little bit more intimidating to you, I think, because they're hitting registers that are actually part of the processor itself. Instead of going to a high-level language like C, well, we're in C, but instead of referencing things in a high-level way, they're referencing actual registers in the microcontroller. And so you have to know details about the microcontroller to know what this is doing and to understand it. So they're actually, this is an OR equals. What the heck is that? Well, you know how in coding you can write A equals A plus 1. Now, in a math sense, that doesn't make any sense, right? But in coding, all that means is take whatever A is right now, add 1 to it, and put it back into A. That's all A equals A plus 1. Well, another way to write that in more compact form is A plus plus. Just add 1 to A, okay? Or you can simply say, how does it go? A plus equals 1, I think is the syntax. So what that means, it's just a shorthand for saying take A, add 1 to it, and put it back in. Okay, so what they're saying here is take this, which is actually a register, OR it with this, and put it back in here. That's what this OR equals. It's a shorthand for saying this equals itself ORed with this. It's just like plus equal is a shorthand for A equals A plus whatever you've got after it. Okay? So there's a lot of compact ways to say things, but it becomes very confusing. You have to know what these things mean. So anyway, they're hitting low-level registers here, which is fine, but you got to know what those registers are, and eventually we'll have to learn it anyway. So this was a less clear way to do it, and I'm glad I found this because it sounds a lot more understandable. So I've got to wrap my head around this, figure it out, and probably rewrite the game because I don't know what I've done with mine. And then I'll demonstrate it for you guys and show you the code. All right, let's continue in the student's code because you can see it operate. You can actually press the button, insert a coin, and see it operate. Now, it's not operating quite like I expected. It's not operating exactly according to the rules that I set up in the game. I think I can win it though. I think we do that. Nope, I missed it. If I remember right, I allowed the students to change the rules a little bit so the game made more sense to them last time because they were all struggling to get it to work the way I wanted it to work. They were pretty close to getting it to work the way they wanted it to work, so I let them all change the game. So I don't remember how his rules went exactly. And I don't know why it's doing the same thing over again. I would expect it to move on and let me try again, but it's not doing that. Pressing the button doesn't help. I'm going to reset the Arduino. And so now it's trying to get my attention to get me to play the game. I insert a quarter. And I think the way he set it up is it flashed random LEDs and then flashed the particular LED, this one now, it's all the way on the end, that is the target. And then his game, instead of flashing random LEDs, just went back and forth so that when you hit the button when the right LED is lit, it flashes all of them at once saying that you've won the game. Now why is it not communicating with us? I'm playing the game so that you guys can see the serial monitor come up. I've inserted a bunch of commands so that when, for example, the function win is called, I had it set up so that it would print win to the terminal. And I don't know why it's not doing that. Let me try again. Serial monitor, if I reset the Arduino. Okay, so now it's running. We'll insert a quarter. The special LED will flash in a moment. Happens to be the one all the way on the end again. And I'm going to press the button outside of, or off of the correct LED. It's still not giving me anything. I don't know why. It did a moment ago. I don't know what I'm doing wrong here. But the idea is that you can put commands in your code so that when the code goes to that section, you can print out to the terminal and you know that the Arduino managed to get to that section of your code. Another thing you can do that's really handy is instead of just printing text to the serial monitor, you can actually print the value of variables. So if I was curious about what lit LED was, I could say serial.println lit LED and it would print out the value of the variable to the terminal so I could see what it was. Now, if all you do is print out a bunch of numbers to the terminal, it can be difficult to determine where they came from. But anyway, so the structure of the code's not the best, I think. Let's see how it's played. Let's go back up here. Interrupts, what is this? This is simply a command that enables interrupts. Sometimes you don't want interrupts to happen, and so you can disable interrupts. But while interrupts are disabled, you run the risk of not noticing that something happens, or missing a button press. this. Okay? Why he enables interrupts several times throughout his code, I don't know. I don't remember if you have to do that at certain points. I don't remember. I'll have to figure that out and come back to you and tell you. So anyway, his loop is simply this: enable interrupts and call the function attention. And attention should, you want to name your functions so that they make sense. Attention should be getting the user's attention so they'll play the game. That's what I think it's doing. He could have really taken all this code and replaced this and just put all of that function inside of code. It probably would make more sense from a structure standpoint. But anyway, if play2f, which is a variable, is equal to 1, this is a condition. If you put play2f with a single equal sign, like that, you will actually set this variable to the value 1. And the result of that operation is success, and so the evaluation of what's happened here is 1, and this will always be true. Okay? So if will always go to this, it'll do the first thing, it'll never go to an else. Anyway, so a little bit of C information there. So if this variable is in fact 1, then the function play2 is called. Now what is play2f? Well, play2f, if you notice, it's right here, it's a variable. And I think it should be volatile because I think that it was supposed to be, I think he used that inside of some of his interrupt routines, and I don't remember what all his interrupt routines were. Play is one of them. Let's go look at play. In fact, that may be the only interrupt routine. Yeah, here we go. So he is referencing play2f inside of a interrupt service routine. So a subroutine that's called by an interrupt. So I think play2f should have volatile in front of it. I'll look through his code in a little more detail and probably know more next time. But that could be why it's not working quite like I expect it to work. Because when you don't declare your variables that are going to be changed inside of an interrupt service routine as volatile, it can mess things up. All right, so he detaches interrupts and then turns interrupts back on. I don't know if when you detach an interrupt, if that automatically turns interrupts off. I don't remember. We can find out pretty easily. All we have to do is go to the Arduino reference and look up interrupts and see when you have to turn interrupts back on. We can look up the, instead of attach interrupts, we can look up the interrupts function. Okay, so syntax is interrupts. Parameters, you don't have to give it anything, it returns no result, so it's like a void. This code doesn't tell us the answer because no interrupts turns off interrupts and then interrupts turns them back on. Let's check detach interrupts because he's putting interrupts immediately after detach interrupt every time. Turn off the given interrupt, so turn off interrupt the number of the interrupt to disable. See attach interrupt pin, turn to undefined. I think he didn't understand much about interrupts, and so I think he was just making sure they were on after each time he did something with interrupts. I'm not sure. I could be wrong. It could be after detach interrupt, you have to turn them back on. He figured that out. I don't know. So anyway, he's got all these sub-functions, and that's a good thing, but it makes it confusing in figuring out how the program works. Like I said, there's always more than one way to write a program. And the algorithm you use for writing the program, you really need a plan ahead of time. I didn't tell you guys that. And you probably started really struggling with it. If you had controls with me, it's something I mentioned in controls, is that you've got to figure out how you want this program to do what it's supposed to do and break it down into smaller sections. When I was in high school and I made that Tetris clone in assembly language, the first thing I did is I took out a sheet of paper and I wrote down how I was going to break down the code into different modules. For example, in Tetris, you have to select a particular shape, right? You guys have all played Tetris. You have to select a shape. Well, I thought, well, you know what? I probably need a section of code that somehow selects a shape. So that was one of the modules that I decided to write. Okay, I needed a module that monitored the joystick input. Okay, and once the joystick input was up, down, left, right, or fire, call the correct section of code that deals with that. Okay, so this is years ago, back on Commodore 128. All right, so I needed some code that could take a whatever shape I had and move it down one level without overriding what was already there. It had to detect what was already in place. Okay, so I just broke the code down into several different modules, each of which had to do something a little bit different, and then put them all together and make them work together. So you got to break a big problem like this down into smaller pieces in order to solve it. And interrupts will be one of the tools that I think will be very valuable, but I think timer-based interrupts are going to be much more valuable, okay, than what this student did is I told the students, hey, you're going to have to use interrupts to solve this problem properly. He said, okay, great. I'll use an interrupt somewhere because the professor told me to use it. And it was just detecting a button press. Well, that's not really the purpose. You want to use the interrupt to your advantage. Okay. Now, there is an advantage of using the interrupt to detect the user's fire button input, the trigger. Okay, that can be useful. But he used interrupts for both the coin insert, I think, and the button press. So, all right, well, I'll stop talking. I just wanted you guys to know that there's this thing called interrupts. I'll tell you more about it later. Right now, what you should do is, if you're really struggling, you should probably step back and figure out, how can I break this down into pieces? Okay, and write that down so that you know what your goals are. Okay, questions, comments, anything else? Okay, we will extend the due date. I expected we would have to, and that's fine. My goal is for you guys to learn, not to rush through all this. So I want you guys to succeed on this, and I think you will be able to now that you're in groups, and I'll come around and help you again, probably now better than before, because before you were just trying to figure out how to put something together to get something to work. Now I think I can help direct you a little bit more, now that you realize you probably need a thought-out structure to the program. Okay? All right, thank you guys for your attention.